Okay, now 39 is just like 37. Let me read it. It says, a man's gold wedding rings has an inner diameter of 2.4 centimeters. So that's 2.4 centimeters. So he has a gold ring. We'll just draw a little gold ring, and that's the diameter of it. Okay? And that's at 20 degrees Celsius. All right? And so, if the ring is dropped into boiling water, what will the change of the inner diameter be? Now, this one is a little tricky because, so in other words, we're going to change the temperature to 100 degrees Celsius if you drop it in boiling water. Well, the ring will expand in a linear fashion. So really, what's the relationship between the diameter and the circumference? See, this is the confusing part. Do you do the area or do you do the length? Well, this will expand in a linear fashion, so that the circumference is really pi times the diameter. Well, this circumference is linear. Does that make sense? So if it changes, whatever that linear changes, if I multiply it by pi, that same, in other words, if I multiply this by 2, I also have to multiply this by 2. So whatever the circumference expands because it's linear, right? So will my diameter. So what I'm going to use is I'm still going to use linear expansion, and I'm going to use the length, the original length. But I'm going to algebraically, because I want to see how much it changes, so I'm going to multiply both sides of this equation by L naught, and this cancels with this, but then I get L naught alpha delta T. And as I showed you on the previous example, if I convert both those to Kelvin, what is delta T though? Going from 100 degrees to 20 degrees, or 373 down to 293. Well, it's the same. It's 80 degrees, right? So what I have here is 2.4 centimeters, which is really 0.024 centimeters or meters in this case. And then the coefficient for gold, which if you look that up in your textbook on page 369, the thermal expansion for gold is 14 times 10 to the 6th. So we say 14 times 10 to the negative 6, sorry. Okay? And then delta T is just 80 degrees because it's 100 minus 20 or 373 minus 293, right? So it's 80 degrees. Now if you multiply that all together, you get how much it changes, which if you do that on your calculator, let's just do it on the calculator so I can model that for you guys. What did I say it was? It was the original length, which is 0.024, times 14 times 10 to the negative 6 times 80. And I get 0.0, is that the right answer in the back of the book? I hope so. Let me see, I got it.
Yeah, why'd you add?
You added the 0.20.
Did I add it? Oh, that was just a mistake. 0.024 times 14 e to the negative 6 times 80. There we go. That's what it is. So we've got 2.7 times 10 to the negative, so 2.7 times 10 to the negative 5 meters. Right? And if you convert that, it's like 2.7, there's it's like 0.00, how many zeros are there? 2? Yeah. 27 centimeters. So that's pretty small. So it'll expand, but not a whole lot. Does that make sense? Any other questions?